This is an old building that was derelict for 15 years.
If you read all the newspapers, see what is going on, these are the type of installations where you think new technology would not work. So any solution that we do put in, it has to be reliable. We need to make sure no matter what happens, this room is always going to be kept to temperature.
They had gas central heating that didn't work for many years. Whatever was there, the efficiency was very, very poor. And we decided to use air source heat pump as a source of energy rather than gas central heating.
The emitters are critical for the efficient running of a heating system, in particular in a building like this, which is mixed use, unknown fabric, and intermittently used throughout the day. We obviously supplied and installed the ThermaSkirt system, and fundamentally what it is a radiant heating panel that's disguised as a skirting board. It's about taking all the client's needs and how the building's going to be used, and then putting together a collaborative approach by manufacturers to basically say these products will work together well, and here's how they're going to work together. That's going to achieve an optimal solution. Anybody can chuck a load of products together and a load of data sheets and hope for the best, but for the optimal results, that's when you've got client manufacturers like Discrete Heat and Panasonic working hand in hand to actually deliver what the client needs and expects.
So this unit here is what we call the Panasonic Big M Series unit. What makes this unit the correct one for especially the side of this building here and for the project to be able to cope with that heat load demand is it's what we call a T-cap technology. And by that what I mean is this 30 kilowatt unit is still a 30 kilowatt unit at -15. But in addition to that, we can start cascading more than one together. In actual fact, we can cascade up to 10. So this room here is the backbone of the whole system. We can see the pipework running all the way through, delivering heat round to the whole building. And this is actually the most crucial part of the system, because we get this wrong and we size this completely incorrect, the whole system will fall down. But first of all, when you do walk in, I think the key one is you can feel the heat straight away. Yes, we have changed the windows out, but we've still kept the original window sills. If we look on the room over the side over here, we've got that fantastic fireplace still in situ. And what's even more impressive, if we look how high the ceilings are, but you can still see the beams. It's the original beam. So the character of the building, it's great to see it come back to life.
You'll never compromise the use of this building because of the way that the system has been designed, whether it's going to be used for clinical, operational, or office use. You've got something that's fit for the future. You can bring buildings like this one back into use.
When we look at systems like this is what creates it the ideal solution for a building like this, which of course needed that little bit of love, but in actual fact we can bring it back alive.